A homogeneous system is a system AX equals B where B, the constant vector, is equal to 0. And these kind of systems, we'll see they play sort of a special role in linear algebra. And it's a theorem that homogeneous systems are always consistent. So in other words, this is just a rephrase of saying that AX equals 0 always has a solution. And I bet that you can actually prove this theorem on your own. If you want, you can pause the video for a moment and see if you can see why it must be true that a homogeneous system always is consistent. Okay, so assuming that you've thought about it for a moment, if you look at x equals 0, it's a solution. Because a times 0 is always going to give you 0. That's it. Not much to it. Okay, and so this solution, x equals 0, when it's a solution, this is what we call the trivial solution. It's often not much good for anything. So let's take a look at what this says here. So just making a couple of observations. And so what do we have? So we've got that, first off, x equals 0 is a solution of ax equals b. Actually, if and only if, so this goes both ways now, b is equal to 0. So we just saw that if b is equal to 0, then x equals 0 is a solution. But notice that if 0 is a solution of ax equals b, then that means we can substitute 0 in for x on the left-hand side and have a true equation. And that true equation would say 0 equals b. So it actually goes both ways. And then we also have that the reduced row echelon form of A is equal to the identity if and only if x equals 0 is the only solution of the homogeneous equation. Okay, and so this follows from the fact that we saw that in the examples previously, that the reduced row echelon form of A being equal to the identity, that gives you a unique solution, because from that reduced row echelon form you can just read off the values of the variables. They're totally fixed. Okay, and so this one is often written, and I'll write this in the future as saying ax equals 0 implies x equals 0. So this is shorthand for saying that the trivial solution is the only solution. Because it's saying if x is a solution, then x has to be 0. So there can be only one. And we have a couple of further observations. So let's see. First off, a homogeneous system can only be row equivalent to another homogeneous system. And so to think about that, realize that if it's homogeneous, then there's nothing in the last column, right? It's all zeros. Nothing but zeros in the last column. And if you do row operations, you're going to be just taking scalar multiples of those zeros, or swapping zeros, or adding a multiple of one zero to another zero, and all those things are just going to produce more zeros. So all that's going to happen is throughout the steps of a Gaussian elimination where you do row operations, you'll always just have a column of zeros there at the end. So the main point is that no row operation can change a column of zeros. And then this means, or that we have the following consequence, and that is that for a homogeneous system, we don't need to form the augmented matrix. So in the next video, I'm going to do an example of a homogeneous system, and we'll see that there's no sense in writing this last column of zeros every single time a column of zeros. It's pointless busy work, so we will skip it.